I'm Whitfield Diffie. I did 1 good hour of work in my life just about 34 years ago, the spring of 1975, created something called public key cryptography, and I've been making a living off of it ever since. Some other people have made an even better living off of it ever since, I'm happy to say. And I get presented with my panel. I find 2 of them I've known for quite some time and 2 of them I haven't. So let me just introduce them as best I can. Steve Crocker is somebody I've actually known even longer than Vint Cerf. I met him when he was at MIT 67, something like that, before I went to Stanford. And he, I think he's had his, sort of fingers on the pulse of ARPA's neck ever since then. And been working in security for quite a number of years. One of a couple of people I'm going to introduce whose activities move too fast for me to keep track of them, so I'll let you all say how I misrepresented you when you get the floors yourselves. The next 2 are internal here and probably better known to many of you than they are to me. Chris DiBona is described as browser security, which I assume means Chrome. And I'm told that Chrome goes a long way out of its way to get isolation among various things that need to be isolated. Eric Grosse seems to be bipartite. He's described as application and network security. As a practical developmental matter, I see those as 2 different things, and maybe they should be harmonized, but I'm curious as to how they get unified in one person. But here it comes from Bell Labs, and so, the universe of my youth, that means it can do no wrong. And finally, Howard Schmidt, I can't keep track of him either, but he's been at Microsoft, at the White House, at eBay, but then eBay sold him, but I've forgotten who they sold him to. And the only... that's exactly what I was thinking. I mean, it's like Jay Leno quoted Schwarzenegger saying about the budget crisis, we have no choice now. We are going to have to sell Senate seats right here in California. So selling off his personnel is the last resort of the unscrupulous corporation. At any event, why don't you all come up? 2 out of 4 of us have slides. 2.5 out of 5 of us have ties. I have mine in my pocket. And I was told, I guess, that Chris DiBona's slides come before Eric Grosse's as the only guide to what the order ought to be here. Okay. So let me hit you up in alphabetical order. Steve, why don't you go ahead and... Actually, let me have Mike. I got carried away by introductions. So I think I'll also take a second to make an opening statement, since after I let other people loose, I may not get a chance. I think that the internet is unique in a combination of things. First, if you compare it, I think lots about, there are important things to learn from history, but you can also learn a lot that's misleading from history. And I think in security, we've absorbed a lot that is very misleading. And one critical thing about the internet is that it's a network intended for friends to talk to foes. If you look at a traditional military command and control network, which is where traditional security work was done, you have a network meant for friends to talk to friends. And when you add the technology that we've developed, which was indeed intended for a diverse community, to the easier problem of a less diverse community, you can get quite good results. But we still aren't ready for prime time in a truly diverse community. Now, you might answer that by saying, but wait a moment, there have been networks before that didn't just connect friends. Look at the telephone system. For that matter, look at the mail. And that much is true. But the key point about the internet, in my mind, is how much it is its own housekeeper. So the internet is a matter of a lot of code running. from microcode to applications. And that code is developed and updated and maintained over the network itself. And that raises the security standard required in an environment that makes it harder to achieve that security standard. So with that, I will incidentally, I'm talking this way because I was at a 2-day celebration of 100 years of British intelligence in a conference facility in which the common room had a ceiling about this high, and you were shouting at each other. You know, spies get together and conspire, but you have to shout to do it. So I apologize. At any event, I let loose the rest of the panel who can correct me.
I guess this is live. Thank you very much. You caused me to flash back, Whit. So we met. My recollection is when you came into my office and asked if you could borrow one of my math books when we were grad students at MIT. And I remember being pleasantly surprised that I had anything that would interest anybody who was already at MIT, since I felt overwhelmed by the environment. The other thing you mentioned was having, how'd you put it, fingers on the neck of ARPA. They can.
That's the pulse, not the.
Yeah. So that was the question: is this the fingers around the neck, or is this finding out whether DARPA is still alive, which is in some respects an open question. So I'm here in a very narrow capacity with respect to security. I've been working on what looked like an easy, straightforward problem. Actually, in my life, originated when Whit called up one day and said, "We got a serious problem. There's what he described the basic issues of cache poisoning. It had been demonstrated. In a way that rocketed up through the higher levels of the government, presidential science advisor, and we started an urgent project right away to fix the problem. It was obvious what to do: add cryptographic signatures to the DNS system, early 1990s, and it's a little sad and embarrassing as to what the long path has been for that. The good news is that the specs are pretty much done, and we're now in the deployment process, which is long and equally painful. So I want to give you a very brief walkthrough of this. I've been cautioned that I have far too many slides, but I intend to move along real fast. So recap status and current issues. Here's a picture of what DNS looks like, and there are two sides to this. To the left of the cloud is the provisioning side, putting the information together, making it available, and on the right side is the active part, the reason why it's there, asking the questions and getting the answers back. And here is what we'll call the Google effect, perhaps, or the web effect. There's a rather surprisingly large number of queries for DNS just in looking at a single page these days. This is, you think you will look up something, get an answer back, and then you go and get that information. So that's the reference for a single page off of CNN.com. Those are DNS lookups, not the content lookups. Here's where things can go wrong. The arrows all point to places where it's possible to tinker with and subvert the information. The black arrows are places where you need insider access. The red arrows, unfortunately, are the places where the attacks can come from the outside, and that's the area that we want to fix. So in ultra brief, this is not the place for a tutorial, and I suspect 95% of the people in this room could build this stuff. So you have zone administrators sign records, end systems have to check them, and if the bad guys want to insert false answers in the middle in one fashion or another, either on the fly or by poisoning a cache or whatever, that gets detected and in principle discarded. So one of the big questions that comes up, not in the inner circles, but at the next layers out of why should I adopt this? Is this going to solve all my problems? And the answer is the usual. It does part of what you need, and it won't do everything. Is it necessary? Yes. Is it sufficient? No. It won't solve DDoS attacks. It won't solve identity theft. It won't solve a bunch of other things. But it is a base layer that a lot of things are going to be built on top of, and it's important to implement it itself. So getting down a little bit, there's a couple of chicken and egg problems. One is that in order to work, you have to have zones signed, and you have to have validating resolvers check those signatures. Why should I put it into my resolver if there's nothing signed? Why should I sign anything if there's nobody checking it? And until you get on the right side of that cycle, it's not virtuous. So we have to get zones signed. We have to get signatures checked. As it turns out, it is easier to put the pressure on getting things signed. And so, in fact, the place we are is that we have more things signed, and we are in an earlier but not zero stage of getting signatures checked. There's the status. There are a growing handful, I should say, of top-level domains that are signed and in operation. If you're not familiar with all those two-letter acronyms, that's Sweden, Brazil, Bulgaria, Puerto Rico, the Czech Republic, and Thailand for country code top-level domains, and .museum and .gov, which is the U.S. government internal, one of the U.S. government's internal ones. .mil is the other. Coming soon, Canada, UK, Portugal, .us, Australia, India, Malaysia, Switzerland, all testing, .org, .edu, .mil, .net, and .com all have announced various degrees of development and likely to come. And the route is very much under discussion, and there's just a huge amount going on there, and I'll say a bit more at the tail end. Dan Kaminsky's work last year is probably the strongest and best thing that ever happened with respect to DNSSEC, despite all of the years of effort that we've put into it. We have to raise him as the poster child for DNSSEC. The U.S. government has purview over Gov and Mil, of course, under .us and .edu under various contracts, and it has talk about fingers on the neck, fingers around the neck of the route. There are government regulations in depth saying that .gov has to be signed, and below .gov all of the subordinate zones by the end of this year. .mil is coming. There's federal standards that are not only forcing the adoption inside the U.S. government, but will have a cascading impact on vendors. And that is, one would have thought that the power of the purse of the U.S. federal government would have waned in the IT area and could not control anything, but it still has a quite powerful effect. On the validation side, on the checking of signatures, ISPs are beginning to operate validating resolvers. Telia in Sweden rolled out in parallel with the Swedish registry when they rolled out the first full-up operating top-level domain that was signed. Comcast in the U.S. has been a leader, University of California, Berkeley, and I think there are a bunch of other places that are beginning to run validating recursive resolvers. The list will grow. What are the issues? Well, are there performance problems? And the answer is not really. Yes, it is true that signed answers are longer than unsigned answers. Yes, it takes longer to check. Well, you have to spend time checking the signatures computationally and bandwidth utilization and so forth. These are small potatoes. One can make them look very large by saying, oh, look, the signed answers are 3 times bigger than unsigned answer. That's out of a single-digit percentage of the total bandwidth that gets consumed, perhaps at best. We did discover that some of these small routers and firewalls have trouble processing signed answers, and there's a report reference there. We did some careful experiments, documented the tests. Comcast redid those and had a summit meeting several months ago and pressed vendors, and I think that over time we will get that problem fixed up. All right, so what isn't in good shape? We need a rather complete, predictable response model. What happens if a signature doesn't check? What happens if you ask for a signature and it isn't supplied? Those two questions don't have crisp, clean, fully implemented answers throughout all of the end-user software. Even Microsoft is fully on board. Nobody wants pop-ups saying a problem's been discovered. Okay? Not really. And I don't appreciate you asking at this particular moment because I can't do anything with the question, right?
Can't even report it.
It's just completely the wrong thing. We need products and services that make this easy. On the product side, Secure 64 and other companies are producing appliances. On the services side, Affilius has brought out a managed DNSSEC service. I expect that Ultra DNS run by Newstar will be along momentarily, and I think this will move along nicely so that it is not going to be necessary that you have to become an expert at all the different aspects of generating keys and managing the key rollovers and all of that if you want to outsource it. If you want to do it, that's fine. It's all well documented. On the signing side, we have to have tools and other mechanisms available to make it easy. One of the chicken and egg problems that we're dealing with is not only the checking versus signing, but within the signing community, you have the root, you have top-level domains, you have enterprises below that. What happens if an enterprise, so a point that I should have mentioned is that DNSSEC depends upon a chain of signatures from the bottom up, so that if an enterprise has signed its own, its signature is vouched for by the top-level domain that it's registered under, and the top-level domain signature is vouched for by the root signature, and the root key is then made available broadly. Would that it would all be done, that would be great. We're in a state where the tree is full of holes, or less charitably, there's only a few places that are filled in on the tree, and it's mostly holes. How do you operate in this incomplete state, which we're going to be in some degree for a very long time? You have to have a way of tying together the loose ends. Trust anchor repositories is the term of art. A bunch of things that are not perfectly worked out about all of that. And then you have some big players like Google and Akamai and others that play very, very fancy games with DNS, and that when you bring those fancy games together with the design of DNSSEC, there's some technical challenges there. And I have been hoping and having discussions on the side that Google, Akamai, and others will take a forward posture in this. And the results are encouraging, but leave it to them to make their own announcements. Applications. What do you do with all this besides take comfort in the fact that you've got the right, that the domain name translates to the right address? Well, the interesting thing is that once you do all of this, you actually have a platform that other things can be built on top of. Should we mention that? Would that scare people? Or should we mention that and excite people? An open question. Meanwhile, off in another part of the space, the email people are working on DKIM domain keys for checking email origin. And those keys are stored in DNS, but not tied to the DNS signature process yet, although it looks like it's obvious that they should do so. And there are plenty of other public key infrastructure apps that could and will exist. I want to mention a thing that is quite new. So the last few days we've put together a symposium looking at the specific technical issues of what it's going to mean to roll out a signed root. The email address there is for submitting an application or requesting information. Here's some topics that we'll be looking at. It'll be a small symposium about maybe the size of this or smaller, and the results will be made public. And that's it. I have in this slide deck, if it's distributed, some backup slides on other things. And but thank you. Yeah.
I was looking terrified at that 20 out of 36. I'm going to have to throw this guy off the stage. And then suddenly, it's a little like you just read Magister Ludi. Suddenly ends in the middle of something, he tricks you, because there's a long series of appendices, so you still think you're in the middle of the book. How should we handle this? I don't know how it has been handled. Questions in the middle, sure.
Yeah, one of the obvious questions, and it sort of goes to the discussion with Eric. One of the next steps after you get to what you think is the right site is actually using certs to verify that you're there and setting up a encrypted pipe. Google, along with a bunch of other players, have done a marvelous job in the last 18, 24 months at the CA Browser Forum in coming up with that solution. And there's no reason in the world why basically EV certs shouldn't be rolled out worldwide to attack the cybersecurity problem. In fact, what's terribly embarrassing is even within the United States government, I'd love to see Eric do this next time he's in Washington, try going to a U.S. government agency website and see what you get in terms of a cert. See how many are using EV certs. Bad news is most of them are broken. So the government agencies themselves are not even using the technology. So one of the obvious next steps is to capitalize on what Google, the browser vendors, the CA vendors have done in this, producing this marvelous specification and just getting it rolled out worldwide.
I'll give you each a microphone.
No, I have nothing to add to that, so I'll just pass it.
Eric, I can answer. Should I answer? EV certs have a lot of latency issues. Hi, I'm Andrei Broido. Yeah, the problem that we have with EV certs that they have much worse latencies. So it takes more time actually to check EV certs.
Anyone else want to intrude on our
I knew they're dim.
Okay, so Vint asked me to speak broadly about browsers, and I asked him if he would mind specifically if I sort of told the story of security behind the Android handset. And there's a fellow here from Chrome if you want to deep dive into sort of sandbox design and the rest. So if you have any questions, I'm sure you can answer those. Isn't that great how I can volunteer people in the audience? I'm Chris. For the purposes of this discussion, I guess the background that matters is my time at the State Department as a cryptographer, and after that, working on the Entrust CA when Tandem used the Entrust CA for the Singaporean government. So, as you know, Android is a Linux-based device, and there are a couple of cell phones that have been out for very many years that use Linux as the base for the device. And there's some really interesting sort of things that you get for free with Linux that's pretty awesome on a cell phone. The Linux security model is the bog standard Unix users and groups and user IDs and the concept of root. And it's something that we're all very, very comfortable with, but it's also pretty solid. It's pretty well thought out. In a lot of ways, Linux distinguishes itself by trying not to innovate too much in security and thus make things insecure. And we understand it. So it's sort of easy enough to lock down. Linux in general has a problem in that people are aggressively advancing subsystems, and so sometimes you'll have security problems, and our SREs and sysadmins and our production network planners here at Google are constantly trying to ensure the security of the Google network, and you see this across the internet as a whole, and it's both been a pretty good business for Red Hat to help people keep up to date on these things, but also it's been a very big challenge, considering I think that 30+% of the internet is running on top of Linux servers. But it's not significantly broken, and that's great. And I think the problem for some of the people who have tried to fix security with regards to large-scale and fairly complex role-based systems, where, for instance, Netscape can talk to Netscape and just Netscape and its file space, but not go outside it, like you would maybe program with a security-enhanced Linux model, which came out of the NSA, is that it's very complex to manage for large installations, and it's had other issues. And specifically, if you look at Linux in an environment where the battery is actually quite precious, when you start adding these things, you can actually destroy the battery profile. For instance, the new update of Android that's coming out, Cupcake, we had to take off the net filter and IP tables layer of the operating system. Now, a lot of people say we're doing this because we want to break tethering, because that makes certain partners happier, I think. But in reality, it was destroying about 25% of the Wi-Fi network stack's efficiency. And it was also hurting battery life. And I wouldn't say significantly, but it was single percentage points. So you have all these really interesting trade-offs that actually affect more than just what people think. So that's pretty interesting. Now, cellular phones are really interesting as a threat space. We've seen actually already, not on our device, thankfully, but on other devices, tricks to make people call, 976 babe and things like that are, a penny, or $1 per minute extra than their normal charges to actually make money directly. And that was fairly popular about 3 or 4 years ago, those kinds of exploits against Symbian devices and others. There's also social engineering techniques where you would SMS somebody with a number, and they go, oh, I have to call back my mother. And they're actually not calling back their mother. So those sort of social engineerings, you can't really fix that, in my opinion. But there are other things that, in a lot of ways, as phones become more like computers, they have the same problems. They have a lot of our contact information. They can be used as platforms to send spam. And there are other things where you can brick your phone, and you can brick other people's phones, and that's no good. So another thing that's very, very unique to cell phone networks, and even to a degree certain cell phone towers, is that, unfortunately, the cell phone towers are way more brittle than you might expect sometimes. When we were developing the Android phone, we had a bad habit of sending malformed packets because we were really bringing up the phone. We were sending unexpected packets, and this was actually bringing down the local cell phone tower's data model, which is kind of shocking if you think about it. SMS and voice were still very, very reliable, but you could destroy the network stack on the tower if you send the wrong kind of packet. And you say, well, wait a second, how can you create an open operating system that can do that? Is that allowed? And it's allowed, it's just tricky, right? But then a lot of people were worried about people getting root to their devices and thus causing those kinds of problems before the manufacturers of the cell phone towers could push out patches that would keep it from happening. And another thing that people were really worried about and have been worried about historically, when you give users too much access to the internals of a machine like this, is that they manipulate radio power and thus destroy the local spectra's picture of itself. And that's been pretty interesting too, on how the industry has moved around that. So we try to address this at a lot of levels. We address this at the hardware, the OS level, as well as the application layer. So at the hardware, we have a reserve partition, which is where the operating system exists. And we sign the binaries for the phones that ship as part of a carrier. So for instance, the T-Mobile phone has signed binaries, reserved partitions, and users/developers cannot access that area. And I'll say that I say can't, but I'm also very familiar with the root exploits that are out there. We also send over-the-air updates, and we have to ensure that those over-the-air updates are trustable, so that when they're installed, they actually work, and that they actually think they're complete, they are what we think they are, and they do the right kinds of things for the phone. And then another thing that's really interesting about modern smartphones is if you look at the system on chips that these are based on, there are really two computers in there. There's two ARM chips. One runs what we consider to be the cell phone, the operating system, and the other part runs, and I mentioned this earlier, runs the radio, right? And the radio deals with all the issues around cell tower handoff, intercompany, intercountry handoff, and radio power levels. And it's actually very, very difficult to access that part of the chip, and that's very locked down in the case of the G1 by the manufacturer Qualcomm. So it's actually more complex than the main operating system, and they communicate with each other, as I mentioned, through the AT command set. But there's a price you pay for that. One of the things that a lot of people talk about is like, well, what I really want to write is a program that listens to the PCM stream that goes to your ear, and if somebody says, let's meet tomorrow, it automatically puts it in your calendar. And it's like, yeah, we would like that too. It's actually impossible for us to get that PCM stream, though, and we're working with Qualcomm on figuring out ways of doing that. And they're like, but we did on this one phone we got from China back in 1992. And it's like, yeah, but that was in 1992, and things have changed. So what's that? Oh, there it is. Yeah, well, see, this is the funny thing. They're like, but before we would just unplug the cable and then we'd plug it into the other exchange and we could listen. And it's like, well, we don't have party lines anymore. So yeah, and it's funny because there is a phone out there that actually ships using the SE Linux security model. And it's just like boggles my mind that somebody would want to cram that into this device, but not this device, but a similar Linux-based device. It's funny too. I know we're not going to do a collection of anecdotes here, but Linux phones have been shipping in China for I think over 6 years now, and it's been kind of stagnant since we brought out Android. But anyway, So, and another thing we wanted to do is we wanted to create an environment where you can run applications that are written by third parties, and they could talk to each other in sane ways and not actually break the phone. And so we had to make a decision to give the users enough rope to hang themselves with. So if you have a G1, and we could actually talk about providing one for everyone. I could bring over a palette or whatever. You can install software, and it'll say, do you want them to be able to access your contact list, the network, these different parts of the phone? And then the user will say, well, sure, and then it installs. But that actually allows the user to kind of screw up and to brick their own phone if they download the wrong package that does the wrong thing. So we tried to think of ways of minimizing that danger. So the virtual machine that exists on the phone for running the applications has a very specific sort of model. Whenever you start an application, it actually starts with a new, unique user ID. So it helps to keep these things sort of in their own little holes. And then even if they call native methods and they have native code, if that's being run within that user ID context, and then they talk to each other through known interfaces through the virtual machine, where we could ostensibly protect the user. And that's been pretty successful to date. We've had about 15,000, maybe a bit more, applications written and submitted and or released in the wild. You can install applications from the web. You can install applications pretty much from anywhere if you click the unknown sources button. And that's even true on the carrier-based device. So we're actually pretty proud of the model. It's working pretty well so far. And then you've got the app level and the browser level. Now, browsers on phones are really, really interesting because when you think of a browser on a phone, it actually identifies itself as Chrome Mobile, and they share a number of components, but it's actually a different team, although we're merging them now. The browsers can't really take over the phone. They can cause problems inside the rendering engine that take too long to render, can reduce the efficiency of the phone, maybe burn up a bit of battery. But the way that they're created now is they really are just applications on top of the phone. So even in some of the cases where we had a WebKit bug, where a person could sort of jump out of the browser, it would really just crash your browser, and that's not the end of the world. So by sort of sandboxing these applications and keeping them out of the rest of the phone, it works pretty well. And yet we want to give them access to the services of the phone so they can actually be useful. So that's sort of something we have to deal with an awful lot. One of the things we're doing as a company, we've released a package called Native Client. And what Native Client allows you to do is basically to ship x86 code as part of a web page. A lot of you will be thinking right now about ActiveX and the disaster that was from a security perspective. You're right. It's something we're obviously very sensitive to, and we have a contest to see if we've done it right. They're doing basically subsetting of the x86 command structure, so it's all pretty interesting, despite the fact that it totally breaks the idea of HTML. But anyways, the funny thing is though, for all of our good intentions, we're still screwing up. This is natural, and so don't take it as I'm saying we're all a bunch of screw-ups. So like, for instance, when we first shipped it, one of the things we had as we were developing is while it was booting, you could punch in a command and hit return, and it would execute that command as root, which isn't so secure on a commercial device when you ship millions of them. So after we had shipped about 150,000, somebody basically found out if they typed in reboot while it was booting, it would reboot. They're like, hey, how about that? So they typed in rm-rf star, and it bricked their phone. They're like, I bricked my phone, woohoo! Oh shit. But the people who are familiar with Linux are like, oh, that's no good. And so it became like a haha, look at Google, haha. And we're like, so we've made those mistakes. We've made other mistakes. We had a telnet daemon running as user 0. That's no good. And then so we fixed those and pushed out those fixes fairly quickly, in my opinion. So in a lot of things like security always is, it's how humans react when they screw up, because we always screw up. And then you have the issues that are brought about by people who want to have market uniqueness or want to modify how the phone works so that it works within their business model. And that's caused interesting questions around security. And, well, we don't know that we want them to be able to download ringtones. And for us, ringtones are really a file. How do you really want to make that some files can exist and some can't? How do you approach that? And the reality is, and we all know as technologists, that these are kind of artificial distinctions and thus are often circumventable. So, yeah. The other thing that I like to point out is, for all the worry about radios being exploited and all the rest, for the devices where the radios were actually available, for instance, in the Linksys WR54T routers, the number of people who actually changed the power was so slight as to be unnoticeable, and it never became a problem beyond the theoretical. So, and we haven't seen it yet with the phone, and we've shipped a little over 1 million phones. So that's the story, and I'm happy to answer any questions about that. Was that the kind of thing you were looking for from me on that? So, yeah, okay, cool. So, yeah.
Let's find somebody who doesn't think what you said was adequate.
Yes.
You've got him cowed.
No, good. You know, you're our standby. We need a microphone. You just keep it.
Yeah, assign him a microphone.
Yeah, really.
I'm playing a vent role.
The back of its head.
One of the obvious ones is, are you doing anything or planning to do anything with respect to SIM chips?
What do you mean with respect to SIM chips?
Well, interaction with leveraging them.
Yeah, I mean, you can obviously pop them out, pop them back in.
them.
So this is the funny thing. So when a carrier ships a phone, they have a concept of which SIMs they want to lock you into. So we ship a regular dev phone where you can pick whatever you want. You put in the network information that you want, and that's fine. One of the battle we chose to fight with Android was to have an open source cell phone operating system. We know that actually the best cell phone for the world, in our opinion, is one that allows for a free and fair internet, right? A free and fair cell phone marketplace. We also know that if you look at a lot of the marketplaces, especially in the United States, that's going to be slow going. So we decided let's start with an open marketplace if we can get there, and certainly an open source phone operating system, and sort of raise the bar of what people can at least expect from a quality perspective on a cell phone. And then let's fight those battles as we come to them over the years. It's certainly not going to happen overnight. I mean, if you look at like T-Mobile, for instance, they have a policy, a lot of people don't know this, but if you've had a T-Mobile phone for 6 months and a T-Mobile account with a 2-year contract, for instance, you can call them up and they'll give you the unlock code for the SIM. I mean, they've got you. They already know they've got you. You've been there for 9 months, so you're past the part where you can return it in California or whatever. They're happy to give you the unlock code. So there's a lot of reasons why T-Mobile is sort of a good first partner with us. So, but yeah, I mean, we're not going to win every battle right out of the gate, and so to a degree, we've self-defeated ourselves. You know?
Okay.
Hi. So I know you just said you were trying to build a cell phone operating system, not a PDA operating system.
But it is, right?
But let me ask the sort of next generation PDA question.
Sure.
There are a number of people who are interested in making their PDAs smarter and actually having their PDAs. I mean, the cognitive radio is only one example of cases where you would imagine there's an app on the phone generating new code that it wishes to load into the execution stream of at least some of the communications behavior of the phone or some of the application's behavior. It's customizing to its user, it's learning, it's adapting. How do you envision that in this world in which you're trying to, you've got an app which you've secured, but it's generating new code which, right? Or do we just say hopeless? Or, I mean, I've heard people talk about
I actually think it's quite hopeful.
Okay.
I mean, so for instance, there are certain apps right now that have come out where you're dialing a number, but what it's really doing is calling your Skype account and having it dial your number. So we have apps like that right now, which are, in my mind, fairly innovative choices. And there's a SIP client now where if you dial a number, you're really dialing a SIP server. And that was something we knew could work, and we made certain accommodations, but they had to write some native code and sort of work their way through the system to make it work. The thing is, we try to make these things available, and we say, here's the phone, here's access to the different parts. And we know that people are going to do things that we'll consider fairly specious. And our only real leverage there is we'll say, well, listen, we can't put that in the marketplace. We can't, ship that out officially. But if they want to install it, if people want to install this, they're going to do it. So how much are we really going to fight that? How much is that really a problem? So I think we enable it an awful lot. By basically having an environment where people can create general purpose programs. They can exist in the background. They're not super sandboxed the way that Apple does. And so people will certainly abuse that for evil, but who cares? I mean, we feel that it's better for the sophisticated users, right, who are going to click that unknown sources box. That's a significant event if you think about it. I mean, how many people of the 1 million plus phones we shipped actually will want to hit unknown sources and allow that to happen, right? Yeah, these two guys over here, but they're obviously Unix people. So, But yeah, so we've enabled it to a great degree. I mean, you can do an awful lot with native calls. So I mean, it's Linux, right? So at that point, so it's pretty cool. But we have another speaker or two. I don't want to, step on that.
That actually is a good idea. Let's
Yeah.
hit on Eric Grosse. I'm just going to stay here since I was told I was in the way of the video and stole Steve's face recognition or something.
Okay. Been asked me to speak for 5 minutes or maybe a little more about what kind of attacks we see at Google, network and application layer attacks. So I guess that's the context. Of course, that's a bit of a challenge, right? We do see a lot of attacks all day long, so covering everything in 5 minutes is a challenge. I wish, like the earlier session, we had more numbers in this panel, but security and attacks in particular are a really murky topic. If you go to the RSA proceedings, you can see our team, Steve Weiss and John Forflin, gave our best view of metrics on security attacks that are seen both on the outside and within Google. But that's pretty hard to calibrate against my anecdotal gut feeling for what the bad guys are trying to do to us. So let me just go over my perception of what the main attacks are that we face. And I would categorize those into two kinds. There are the attacks that are, in some sense, not really our fault. They're our problem because if our users are attacked, we care. But they're the classic kinds of attacks that happen all over the place, and they're somewhat outside of our control. That's the kind of thing that we still care about, but there's another kind of attack that's squarely ours to control, someplace where we've made a bug, and those are the ones, of course, we have to spend more time on. It's interesting, though, that the actual data breaches, the actual loss of user information, which is my obsession. I'm trying to make sure that never ever happens, tends to happen more in the first category of attacks than the second category of attacks. So we don't actually put our energies mostly where the main problem is. That's sort of an interesting, why is that? I think that's pretty true in risk analysis known through the whole world. People perceive the risk as much more disturbing when it's outside of their control. So in the first category of attacks, what are the things that really do wind up losing people's data? The prime one by far that we observe is malware. It's just rampant out there. It's really a problem. It's a problem for us even as a corporation, but it's especially a problem for our users. When we look at why someone's mail got leaked to the internet or something, in every case we've investigated through our logs, it's turned out that it's because a bad guy was able to somehow steal their password and just logged in from some distant address that individual had never been at, and there was no password guessing involved or anything of that sort. They just had used a password to log in. So that's the number one problem. If you're looking for, what's the main security issue to work on, that's absolutely it. We try to address that in various ways. We have a fair chunk of my team that looks at anti-malware and anti-phishing approaches. As we crawl the web, we're looking using various techniques to try to guess at which content we've downloaded might be malware, and then run that in some virtual environment to see what it does when you execute it. And if it clearly is installing software and changing registry entries and clearly is bad, then we'll flag those as malware, right? So if you do a search, actually a fair fraction of the time, you'll get back a result that says you don't really want to go there because it'll install bad things on your machine. So that's sort of our first issue. This malware is stealing credentials off your disk, it's modifying files, it's executing code, which may be running, of course, inside an intranet and with your permission, so it's really nasty. And we do what we can to protect you from it, but it's fundamentally your machine, not ours, so there are limits to what we can do. We can't even denounce everything that we find because it would be terrible if we ever were falsely denouncing somebody, so we try to err on the side of being cautious. We've made mistakes. In January, I hear a chuckle over here. In January, you may recall a period of about half an hour when we decided that everything on the internet was malware. No, maybe that's not far wrong, but that was a little excessive. So, so we learned some good lessons about how many layers of checking one needs. Fortunately, we had multiple layers of checking, and some of them caught it, but in one place it had slipped through. So malware's one. Yes. Yes. Good. Let's.
We knew in that moment that the things that were actually bad were marked out.
The only time it was true.
It's like the broken clock that's right twice a day.
Yeah.
Okay.
The other thing, and this won't surprise you either, is spam. Right? There's email spam coming in. I switched to Gmail before I came to Google because it just was doing good spam filtering for me, and I was having a hard time even hiring that service from anyone else. So filtering spam on the way in is a tough problem, but when you've got lots of data to work from, it gets a little easier. We also try to work hard to make sure we don't get used to spam others. Right? We've got a lot of mail infrastructure. So there's that. There's other kinds of spam, blogs and people trying to play games with web page ranking and so forth. So those are all classic kinds of problems. At the network level, so when we talk about DNSSEC, now we get into sort of more technical attacks, right? And we absolutely are seeing those. This is a very live problem. As recently as a couple weekends ago, we saw .pr was up there as having a signed, but actually .pr had gotten compromised. So if you tried to go to google.com.pr, you got sent to a malicious site off in Germany somewhere that was definitely not Google. They were pretending to have defaced the Google page. No, actually they compromised .pr. So yes, DNS is a problem. We see poisoning attacks around the world. If you're sending mail to somebody at Google, you have to think about, well, did somebody along the chain of that SMTP store and forward compromise a DNS? Then the mail will get routed somewhere else, right? So DNS is very important. We would love to see security there, and DNSSEC as a way to distribute search would be terrific. So that's good. We see occasionally BGP attacks that affect us. You remember an incident with Pakistan and so forth. We see network layer attacks even at a place like this. It'll be a conference and somebody will hijack DHCP, and you pop open a browser session and try to go someplace, and if you click through a certificate warning, bingo, they've got you, right? So definitely be worried about the network. It's a hostile environment. And then finally, there's at the network layer, there's denial of service attacks that we have constantly here. I think that we're reasonably effective at fending those off, but it's a never-ending game against these. Denial of service. I'm sorry. Denial of service. Distributed denial of service, like pulling teeth. Yeah. So the main issue really with defense there is minimizing the collateral damage and minimizing the chance that someone can take Google's vast array of servers and network capacity and so forth and turning it against either ourselves or even worse against other people. So there's a lot to be done on DOS, and that's another, I would say, like malware, is another very fertile area for research. So love to talk with people about that. Surprisingly, insider attacks are not high on this list. We tend not to see that very much, and we're looking constantly for that around here. I don't know where the 80% of all attacks or insider attacks comes from. That certainly is not consistent with what I see. But malware looks a lot like an insider attack. So from the point of view of detection, it may as well be the same thing. So I said there were two categories, so let's get to the second category, the things where our team spends all its time. There are a lot of things one can do wrong when you're writing web applications, right? There's of course all the classic things we have to worry about, just like any enterprise, making sure the perimeter is secure, making sure that we evolve towards not just network segmentation defense, but defenses that are much more focused on access controls right close to the data. As we were hearing this morning, I completely in tune with that. But from a company like Google's perspective, most of our energy goes into trying to make sure that the engineers writing software and innovating at a high rate have the right tools and education and backup from security reviews and various external audits and responses to outside reports against things like cross-site scripting. So yesterday, I think it was the New York Times, there was an article talking about, what is cross-site scripting and giving an example in line, which turned into a cross-site scripting attack. So it's ironic. This stuff is very, very tricky. Essentially, you have to make sure that every time you're going to put out a page that you're sending back to the user's browser, you know the context that the bytes are in, so you know whether it's JavaScript or HTML or what, and you do the proper kind of escaping for that context and never, ever screw up. Keep track of what's coming from the user and make sure it's escaped. So we're getting better as time goes by at using template systems with auto-escaping built in, but that's still a major source of attacks. We don't actually see any cases where actual user data has been lost that way, but it would be very easy for that to happen, so we focus a lot of attention on that. Cross-site request forgery is another good example, right, where the bad guys can send something to you that causes your browser to make a request back to the server with all of your credentials, cookies, or whatever the mechanism is by which you're authorized, and trick your browser into making some change on the server. In our case, setting up a special custom filter on your account, right? That was a kind of thing that one could do for a short period of time. We found out about it and fixed that instantly, of course. We care about these things a lot. So those are the nature of web application vulnerabilities that we're constantly fighting. It feels like there's some progress. 10 years ago, we would have been talking about buffer overflow attacks or format string vulnerabilities, and those don't come up so often anymore. So we're making some progress, but it doesn't feel like we're getting close to zero. It just feels like we're pushing the ball along, and we've got a different set of things to worry about. Other things that you have to worry about if you're a company like Google is understanding so much about the browser that you know what subtle things the browser may do to try to interpret you, right? So the web grew up in this world where you would be very relaxed about what kind of errors could be in the input. The browser would just do its best job to render it anyway, no matter what kind of errors were there. As security people, we're trying to reverse engineer that process. We publish a browser security handbook that details for every of the major browsers and every one of the different weird features, character set and content sniffing and how they handle cookies and all these different features, how this works so that our engineers can look through and come up with a scheme that will work on all these browsers without holes. That's very challenging. There's another comparable set, it's an easier task, but there's a comparable set of things about proxies. If you don't get exactly the right cache header controls, some proxy out in the middle of nowhere will save up some content that was intended for just a specific user. So that's tricky. So you have to know your application environment. And I guess finally I'd say another part of network technology that's really important when it comes to the EV certs is SSL. I mean, I just don't understand why SSL is not more widely used. Sure, we should worry about the certs, but first, before everything else, at least switch to SSL. So, in Gmail, if you care about security, you should reach into the settings and say only use SSL, because there are people out there taking these hijacked networks and trying to trick your browser into using HTTP, even though you started out with SSL. They'll try to subtly come in on the side. So yes, we want it. So we've ramped up quite a lot of capacity here at Google. And the next step on that front is really to work more closely with the browsers. And of course, the fact we have a browser helps, but it doesn't give us sort of monopoly control or something. This has to be a collaborative effort with all the people out there to find ways to reduce the number of round trips when we're starting up SSL. That's really essential because latency does really matter to people. That's probably the main thing today that would prevent us just from saying, let's just use SSL all the time for everything, right? It does actually have an impact on people. So, okay, I just about stop there. You have a very nice paper out there by Tom Layton on how the network's evolving to push more content out close to the edge, and we completely agree with that. The one security proviso I have is that we have pretty strong physical security around our data centers. I'm pretty comfortable with that. We also are going down the same path of putting caches out close to the user, because that's again the way you're going to get speed, and that's perfectly sensible and easy for public content. Let's say YouTube videos, perfect fit. For your Gmail content, not so sure. Providing the physical security that sort of are guarantees that no one's going to get to your data, I'm not comfortable with. So if the world's switching all to SSL, we have a bit of a problem about how are we going to do caching out close to the edge. So I'll leave you with that. Thanks.
Well, hand this gentleman the mic.
One obvious one is, as you're seeing these incidents, are you capturing them in IODEF or the MITRE or CVE suite? And are you reporting vulnerabilities to anybody, or is that basically an in-house exercise?
So that's an interesting question. Traditionally, Google was focused completely on a server-based thing, where the attitude was, as soon as there's a problem, we'll just patch on our server, and no user even knows or needs to care about that. So it wasn't as essential to have all of those things reported in with a CVE number, so that enterprise security officers could know whether they checked off that vulnerability patch. As we get more client software out there, Chrome say, it does make more sense to report those things. Even though with Chrome, we're taking a very aggressive, we patch everybody, we're not giving you choices, right? Which is maybe a bit controversial, but we are convinced this is the only way forward in security. I mean, the time scale for the bad guys to look at a patch, reverse engineer it, start an exploit, and actually put users at risk means we can't afford this, let the enterprise cogitate on it for a month. That just doesn't work anymore. So.
I just wanted to ask about DDoS, and I mean, you mentioned it, but can you just say a little bit more about the sort of the frequency, the scale? I mean, it's part that it's a problem that is a consequence of the architecture or the infrastructure.
Yes.
Right. And so it would be really useful to understand a little bit more about how frequently, how big, what you would like to see happen to mitigate this effect.
Right. So we get all kinds of attacks, right? There's both UDP and TCP. Enough are TCP that lots of the classic problems about trying to figure out who it is, which IP address is really coming from, is not such a problem. But you can't say anything absolute. Yes, there are still UDP attacks that we care about, and so yeah, we're interested in that as well. What I would really like to see is the following. We currently do all our DOS defense within our own environment. And that fundamentally is the wrong approach, I believe. The right approach, I believe, is to detect the attack here and to push the filters as close to the source as possible. So one of the things I was doing at Bell Labs before I came here was to build a little box that could go into the carrier's network, ideally close to those DSL lines, and a protocol that allowed, even during the network congestion times that occur when there's a DOS attack, allowed some upstream control from an enterprise like Google to the carrier's filtering box, saying, if there's any packet coming from that IP address to me, throw it away, because I promise you I will throw it away. You may as well save your network bandwidth over there. And there are other approaches that have suggested pushing that upstream through BGP and so forth. But it's a bit challenging to make that work in network congestion times. So that's what I'd really like to see. The trouble is it needs cooperation between a lot of different players, and so it's hard to bring that to market.
We've only got 25 more minutes, and we've heard from 4 geeks, and I think it's time we should hear from Eric Schmidt and get a
Howard.
Sorry.
And I'll be around so hold your, come catch me during a break if you have more questions.
Well, I just want to add 3 letters and 2 numbers to the answer that he just gave. That's BCP 38. Please.
Thanks for the promotion. I appreciated that.
Or
Yeah.
the good signers.
Yeah, we all get sent to the Schmidt house one time or another. Anyway, thanks for the opportunity. The good thing about being last is all the really important stuff was said, but I get to sort of opine on it and have a few pieces of it. I want to start out by the comment about Android specifically, and there was, the question about EV certs and expenses and stuff. There was a really neat quote I found one time that says, "There is scarcely anything in the world that some man cannot make a little worse and sell a little bit more cheaply. The person who buys that on price alone is this man's lawful prey." And if we ever see anything going on the internet today, that therein is one of those things that we see on a regular basis. The other thing I want to touch on briefly was a comment that Eric had made, the real Eric, when he was here, about criminality on the networks and stuff. My first movement in this area was back in the days of bulletin board systems, long live RBBS. But when I was running a combination CPM, users group, ham radio, and a packet radio bulletin board systems on, I think, Commodore 64s or something at the time, and started to get notifications about these bulletin board systems used for distribution of child pornography, which is generally pretty much unacceptable. And having been, as they referred to us as at the time, a geek with a gun, being law enforcement, it started sort of down this path of where I am today. But basically, listening to the previous speakers and a lot of the things that are going on, I want to touch on a few things. One of the things, particularly when we start looking in the development world, and this has been a bone of contention for a long, long time. My first recollection of a buffer overrun incident was long before we've ever seen anything around the Morris worm or anything else around that. It was basically a system operator, their system manager, that was trying to get access to a system that couldn't, found out how he could break out of a routine, run some arbitrary code, and get the access they need. So it wasn't even malicious. But yet today we see, and Eric had mentioned about, buffer overruns and these sort of things, even though they may not be relevant to getting attacked, they still seem to be an attack vector that are being inadvertently built into code that we're writing today. And from an international perspective, which what has Vin asked me to sort of focus on the best I can, is what we're seeing now, particularly in some developing nations, the hand-me-downs that we have are winding up in these environments. And I think of some of the developing countries where some of the old banking systems that we have gotten rid of years ago are now those systems that are the core basis of what they're using to do their financial transactions. So the ability that we have today to withstand some of the threats by the modern systems are being irrelevant to them because they don't even have the capabilities there, but yet they're part of that global financial system that we're in today. So and one of the things that I think is really interesting from a DoD perspective, and I've seen this with MOD in the UK, seen it with some of the NATO countries as well, and the number's pretty consistent, that the successful intrusions into their systems, whether it's for exfiltration of data, whether it's to installation of malware, or whatever the motivation may be, and it varies from one end of the spectrum to the other, is running at about 75% plus based on known vulnerabilities in software that have not been mitigated for 90 days or further, that continue to allow someone have access that could have been patched, should have been patched, but for a multitude of reasons were not patched, which gave that foothold getting into the system. And so when, once again, Eric talking about some of the things that are going on that we have been fixing, there's one fundamental thing that we have not fixed. And that's the whole issue of the software development life cycle. We're getting better at it. We're seeing reductions, but invariably we'll still see the same issue. The other thing which touches directly to this subject as well is looking at the mobile community. Now, a number of us have been concerned about this for quite a while, and I realize the work he left on the Android, but yeah, Chris. Oh, there he is. I'm sorry, Chris. You were off your blue ball, and I didn't recognize you. Sorry. But when you talk about the code signing and the things that go into it, especially when the spectrum is opened up to third-party applications that basically run under the context of a root basis that now are trusted environments that then spawn some child process, those are the issues that we have little control over. And I think of, App World on the BlackBerry, iPhone, and all the App Store going on there, all these things going out there, and the progression that we've had. And I'll give you a personal illustration here. RSA last year, Info Security last year were the first 2 years ever since I can remember lugging a lugabout around to some sort of a show because wireless may have been available somewhere. I did not take a laptop to the show floor with me. Everything I wanted to do, I could do a one-on-two mobiles that I had. Whether it was booking hotels, changing flights, doing online banking, finding what the bid was for me when eBay got rid of me, or whatever the case may be, I could do it on a mobile device. And every time I turn around, I'm looking to yet install another application that gives me the ability to do something else that presumably is signed, that presumably is in many cases from a valid source. It doesn't even have to be a third-party malicious malware generating system that basically can still have that same vulnerability, that can still be exploited, that still gives us access. Now, from an international perspective, that's magnified much greater than what we have here because this has been a way of life in Asian countries in particular, and growing increasingly in Europe, where rarely do you see someone walking around with a mobile device hanging around their neck and doing everything they need to do with it. So if you start looking at that natural progression, and the thing that many of us have been championing for a couple years now, is as we evolve here, there's always a complaint about fighting the last battle. And we've learned an awful lot from fighting those battles. And we move from the browsers and the internet mail connectors and the servers to the desktops, and then the desktops to the laptops, and now we're moving this entire environment to the mobile environment, and we have to start anticipating these things. The other thing that I think is really relevant, and it's really interesting how we in industry, and my first really insight into this is when I left the White House and went to eBay, and looking at the broad spectrum of things, looking at the whole issue about protecting our assets, our customer data, HR data, all financial data, everything we need to look at. And when it came down to the discussion, but what about the I think at that time it was like 110, 114 million end users, but security is their problem. It's not our problem. And I can guarantee you, every time somebody became a victim of a phishing email or had some money lost out of the bank, they went to the local congressman, it started to become our problem. And so the concept of not only taking care of our resources, our assets, to protect them for whatever reason, and generally good reasons, you have to protect our intellectual property, our shareholder value, you name it. But we also have to remember that the end user now becomes our responsibility, because they have no one else to blame but the browser issue that I'm dealing with now that allows someone to get access to my computer because I didn't update. And therein lies one of the issues. And speaking of that, when we get in that issue as well, talking briefly about the browser issues and the browser, its ability to do things. A few years ago, as we start to roll out EV search, which I'm a tremendous fan of, so want to make that very clear. As a matter of fact, we just did a paper from the Online Trust Alliance on EV search. And notwithstanding some of the technical issues where longer to resolve, longer to get the revocation information back, et cetera, it's still much better than standing out there in a snowstorm naked. I mean, having a little bit of extra protection is there. So, but with this concept, one of the issues was that there was a vulnerability, and if I remember correctly, it was IE6 and below, that allowed you to actually embed a graphic image over anywhere on the page, specifically the URL bar. So what happens, you can actually go out there, go to a malicious site, and the overlay would be a green extended verification validation that you're at the legitimate site. Those are the sort of things that, once again, we have to anticipate. And as we build the next generation of things we're doing, we have to take those things into consideration. And once again, that was related back to a vulnerability in the browser itself that should not have been there, that we knew how not to do that, but nonetheless it took place. How are we doing on time, Whit? A couple more minutes here?
Yeah, that would be good. It would be nice to the people.
Time for questions, yeah. Let me hit on a couple other things then real quick. And once again, another one of my soapbox issues is IPv6, which once again, when I was at the White House, we put specifically in the National Strategy to Secure Cyberspace immediately implementation of IPv6. And of course, I was challenged by many people saying, yeah, but IPv6 is not a security fix. And absolutely true, it's not. But when you start looking at the re-architecture and implementation of IPv6 that includes such things as DNSSEC, secure BGP, IPsec as being sort of the normal state as opposed to a change state, well, clearly that goes a long way to doing what we're doing. And notwithstanding the fact of running out IP addresses in the next year or two, which is our own self-inflicted DDoS if we wind up letting that happen. And let's see, I did have a couple other notes here. I want to make sure I don't overlook here. Trusted. The interesting comment you made on the data set, the data centers and the physical security of that. One of the things we've seen, particularly as we start to evolve into the centralized data facility, co-location, et cetera, one of the concerns we've had, which is not a technology issue, but it's just a human factor issue, and that's access to these things. I think back where I have my various domains, 3 hosted places that I can then go access there, and I want to change some apps, I want to change out a hard drive, I want to change out a server. I can get physical access to that facility, although there may be other applications and other servers running in there that have nothing to do with me. So the whole issue of getting access, that sort of thing, just by a physical issue is something else we worry about. And once again, we start looking internationally where they don't have the resources that we have here in the United States, and that becomes a big problem, where you can go in there. And so as we get better about making things more secure, physical access is going to be more important because people can actually go in and start, dropping some rogue DLLs on systems that you wouldn't have a clue that they were even done. So in closing, I just want to make one quick perspective on how much better we're doing. And if you think back to just the past few years in phishing emails, the first phishing email I got was in 1996. It was an AOL account that basically wanted my user ID and password specifically for the reasons that they were looking to hijack my account so they didn't have to pay for the access. That was back when it was like $6 an hour and 6 cents a minute over that. And that's what it was designed for. Today we call it a phishing email. Where we have evolved to from a technology perspective, think of what, if you were a phishing email, what it would take to get you to be a successful executor of the criminal activity. You have to get through, and I love it. Whoever said it was my first account on Gmail was specifically that, to beat all the spam that was going out there. And so it has to get past the server level at the Internet Mail Connector layer first. Gets into the server, then it's got to go through some internal enterprise or individual spam filtering regime. Then it gets into the client side, whether it's Eudora, Outlook, whatever you're using in there, it's got to get past that layer. Then if it makes it into the inbox, which it may at some point do, and then most new email clients have the ability to turn off links by default, so you can't even click the link unless you do something proactively. Then once you do that, then you hit the browser side, and whether it's Chrome, whether it's Safari, whatever it may be, all have anti-phishing technology built into it. So if you become a victim of phishing email today, you really, really have to work at it. And that's the thing that we need to do as we move forward on the mobile devices and everything else. We have to make it more difficult for the criminal to get to the end layer from a security perspective than it is for us to get where we want to be. Make it much more difficult for them than it is for us. Anyway, that's it. Thanks.
Thank you. I have just a couple. I'm going to take the same prerogative to comment on things played before. Just say a couple of quick things. You were mentioning the general problem with passwords. And tangential to that, let me just note that there are 2 people in the security profession, father and son, both named Robert Morris. And the son is very well known as the author of The Morris Worm. The father is slightly less well known, but he was the chief scientist of the National Computer Security Center. He was also the author of the Unix password encryption algorithm. So I have an exam question. which of these people did more damage to network security? And just, Eric, I wanted to remark on this. I like this, what's the first buffer overrun? Timeshare had one in its password verification. The password, the bit that said you were logged in, was up beyond the end of the password. If you just typed a long enough password, you got logged in. Okay, I understand there's a question already queued. You're on.
Yeah, I guess so. I had a question for maybe the whole panel, which I guess they'll be assembled shortly.
I don't think we should assemble. I think
we should
be distributed. I'll sit over here with a mic.
So we have some security that goes for our channel security. We also have concerns about denial of service attacks, which is kind of access to the network versus the legitimacy of the data that's carried over that. And the thing when I was up there talking earlier, it seems to me that for somebody who's in kind of the research side where I don't have to be as attached to all the things that are there now, a model in which data at rest and data in motion carried over networks is really using the same kind of encryption, key management, and all that would allow us to deposit objects, if you will, messages and so on, in places, and the author has some say about the status of that thing and the use controls. And it seems to me that right now, the way things are, we're kind of far away from that. And so from a, what would you do in research point of view? Is this a worthy path to go down? Basically securing the data separately so that data can be secured outside of the servers it sits in, which relates to the access to and cache data that's outside of the data centers? Or is this already been done and not worth doing?
I think my own view is it hasn't been done. It's if I understood you, very worth doing, because there are three ways in which you find data: in motion, at rest, and in execution. And if you look at a cloud computing model, there are different degrees of control that you can exercise over data in these different modes, particularly low in execution. And so also, particularly given that key management for communications data and key management for data at rest differ substantially in what you have to do, because in the case of data at rest, key recovery dominates all of your other concerns. I think that this is something that has not been done uniformly and is one of the foremost, solvable, immediate challenges, in particular of a cloud viewpoint. But probably somebody...
Yeah, I could not agree more. I mean, we've been so remiss in doing things like that. You look at the entire spectrum where we start. Why is data so valuable to people? Because they can do something with it. If you render it unusable to them, well, there goes the incentive to do some of the things. Unless we can become 100% reliable in writing code that doesn't have any vulnerabilities, that gives somebody the ability to get access to it, well, then we wouldn't need to worry about it, but we do. So you look at that entire spectrum, and you need to have that ability to use the PKI to actually make this entire thing work, and I didn't get a chance to comment. I had a note here about government stuff. If there's anything the government could ever do for me in a technology perspective is pass a law making it illegal to use a user ID and password right away. Just post everybody's social security number on the internet, make it available to everybody, and declare it unavailable for use as well. You do those two things, and then we'll be put in a place where those solutions you're referring to would be on the roadmap, and the roadmap very quickly.
Yeah, so
I have one more response to that question, if I could just get a word in there. We see some interesting opportunities if, indeed, it's protect the way you were saying. So I was really intrigued by your comment that not only is it pushing the protection close to the data when it's on the server, but to such an extent that you can even pick up that piece of data, presumably encrypted, and copy it to a USB drive, and it's still just as well protected. There's some key management I want to ask you about afterwards, but the issue for Google is if it's completely encrypted and the key is held only by the distant user, there are a lot of bulk processing operations that we can't do on your behalf. So we can't speculatively try translating all your mail from English to German so we can there are a lot of interesting things that then are precluded, and so that's a tension that we're struggling with.
So the more subtle way of describing what I was after is not that it would be a single envelope, but rather a hierarchical or a separable role-based envelope where I would say, I'm delegating this chunk of this data to be processed by cloud. The rest of it has the following use controls associated with it, and I control that. Mm-hmm. So I can index it maybe, or maybe you can index it, or some subset of you can index it, and I get those kind of controls. But the key management problem for that is really hard, I think.
There is a key issue, however. 1904, we were confronted with radio. It was so valuable, nobody could ignore it, but it had the problem that it bypassed all existing information security controls. Cryptography rescued us from that. This time we have the cloud, potentially so valuable nobody can stay in business without making use of other people's offers to do their computing for them. But it is not clear, at least to me, how you can give somebody your data to compute with and still protect them to your own use. And that confrontation is going to take somebody younger and smarter than I am to figure out if there is a magic solution. But there are lots of ways in which the technicalities we now know can be applied to make the network more secure from many viewpoints, not from all of them.
Well, it's also interesting. We talk about putting these fairly high ceremony systems around data and around user-submitted content, even around copyright. And I know this is someone is going to say this, so it might as well be me. Sometimes they're too hard for people to do, and not just hard from a technical perspective. They might be easy. They might be hard from a I just wanted to push out this website and forget about it kind of perspective. I mean, one of the things that HTML and HTTP and the internet sort of taught me personally was that it was so easy that anyone could do it, so everyone did. And this is why I feel like the semantic approaches have been failing, is because they sort of require everyone to agree on the semantics thereof, right? So when you create these systems that require a lot of things that the user really never sees, except in that it doesn't prey on them in some way. But the thing that they actually get out of it is now what's left after this pile of hard thing. It just doesn't get done. Otherwise we would be using PGP. We should be using all this stuff. And I think this is also part of why we see so much resistance to DNSSEC, right? People end up giving up the power to just create unfettered without having to talk to somebody else about it. So
okay, we have 90 seconds
I'm rolling
left.
a lot of things into one paragraph there, but yeah.
You choose. All right.
I was first. So we perhaps remember the poor teacher who, as the verdict seemed to say, showed to her children pornography, and this was because her machine was infected with malware. So we here seem to be focusing on preventing this from happening at all, while I'm sort of surprised about the repudiation or non-repudiation of this, like after the fact. Why don't we have any mechanism in place to have this teacher or have us say, here I can prove now afterwards that I didn't do it?
Well, I can tell you, in some of the laws that I know on this subject, quite prior to computers, evidence that you wasn't voluntary isn't a defense. So, well,
having done the computer forensics from the very beginning, there are ways to do that and do the non-attribution. It's a typical ruse used by criminals to say, gee, I didn't know it was on there, but it was out there hacking machines all by itself or whatever. So, but there are ways to do it from a technical perspective. The issue is we should never let it be happening to begin with. And a lot of our discussions turn around that we have discussions about those of us in technology that would not have a problem doing these things. We have to consider the rest of the world, 1 billion users now, probably 2 billion within the next 3 years. How do we wind up making this easy for them and not to become in that position?
It's actually pretty funny. So it's funny. We had this discussion around I don't remember the exact option, but there's an option in Internet Explorer 6 on where basically you can tighten up the security, but if you do that, you break the ability to create AJAX web applications for all intents and purposes. So none of the other browsers adopted this security posture. And in fact, Microsoft says, don't adopt this, because if you do, everything you want to use on the internet won't really work.
But in fact, it would actually solve a lot of the problems.
It's like turning off JavaScript, which solves lots of problems, creates more. Yeah.
And so we talk about like, no, well, if we just do it right in the first place, and I agree with you, if we do it right in the first place, that's great. But if doing it right in the first place actually keeps people from doing something, then it won't matter, right? So it's that problem there. Anyway, I'm sorry.
So I wanted to ask anyone in the know, there is a newly formulated alternative to TCP called the SCTP, Stream Control Transport Protocol, which has a number of built-in security features like four-way handshake, verification tags, different from sequence numbers, and so on. So what is your take, whether it is more secure than TCP or whether it is fighting the last battle, essentially?
Sounds like your alley. Or in league with the broad titles you give yourself.
There's lots of solutions, and in networking, we have to get everybody to agree on something, and that's so hard that, okay, TCP's already out there, and a lot of people using it, it's fine, and we can build SSL on top of that and get a secure connection. So it's not like SSL over TCP is the only possible way to go, but it's already so widely deployed, you need a major increment to displace it.
So, thank you all very much.
Thank you.